Hi all, I am here with my new video on chemical bonding and molecular shape. Let's start. In this video, we will learn about intermolecular forces which are known as van der Waals forces. Intermolecular forces are attraction those exist between molecules or between molecules and ions. These forces are responsible for the solubilities of substances. Example, sucrose, a kind of sugar, and salt NaCl dissolves in water because of the association of water molecules with the molecules of sucrose and the ions present in sodium chloride, which is salt. All of these attractions are known as collectively as van der Waals forces. These intermolecular forces include dipole forces, London dispersion forces, hydrogen bonding, and ion dipole forces. We can compare the strengths of intermolecular forces by examining the boiling points of various substances. Substances with strong intermolecular attraction have higher boiling points than those with weaker intermolecular attraction. In this video, we will learn about four types of intermolecular forces or van der Waals forces. These four types are dipole forces, London dispersion forces, hydrogen bonding, and ion dipole forces. Dipole forces exist among polar molecules like hydrogen chloride, HCl. Each of the molecule of this substance has both a positive and a negative end. The positive end of the dipole is located near hydrogen and the negative end is located near chlorine atom in HCl. Since the opposite charges attract, the molecules line up, so oppositely charged dipoles are close to one another. This is shown as following. Here the solid lines represent covalent bonds and the dotted lines represent dipole forces. Hydrogen chloride dissolves readily in water because of the dipole forces that exist between HCl and H2O molecules. The diagram below is a simplified representation of this association and the dotted line here represents dipole forces. Dipole forces depend on the polarities of the molecules involved. The more polar the molecule is, the stronger the dipole forces and the higher the boiling point. In order to compare the strengths of dipole forces, we must examine substances that have molar masses close in value, and we find that the polar substance has a higher boiling point than the corresponding non-polar substance with a similar molar mass due to dipole forces in each polar substance. London dispersion forces arise because all molecules, both polar and nonpolar, can create temporary dipoles for a short period of time. The resulting forces increase with increasing molar mass and decrease with increasing distance between adjacent molecules. Hydrogen bonding. Hydrogen bonding exists in molecules where a hydrogen atom is present and hydrogen is attached to other element with a higher electronegativity such as nitrogen, oxygen and fluorine. Due to hydrogen bonding present in these molecules like hydrogen fluoride, water and NH3, ammonia, they have higher boiling point than other compounds from period 2 elements within the same group. This combination of elements in hydrogen fluoride, H2O and NH3 allows the hydrogen atom of one molecule to approach the nitrogen, oxygen or fluorine atom of a neighboring two polar molecules very closely, creating an unusually strong attraction between the two polar molecules. Here keep in mind that hydrogen bonding is not a covalent bonding. It is a stronger type of dipole force and occurs between neighboring molecules. The following diagram provides example of types of hydrogen bond. Ion dipole forces. Ion dipole forces exist in ionic compounds such as NaCl, salt, which dissolves readily in water. This solubility is due to the attraction of the sodium and chlorine ions for the negative and positive ends of polar water molecules. As NaCl, sodium chloride, is added to the water, Water molecules surround and separate the ions, destroying the crystal structure in process known as hydration. In our next video, we will going to learn about physical and chemical properties of bonded substances. So please subscribe and like to watch my new videos, and please subscribe. Thank you. Bye.